Thanks to Overlord from our forum, I have got my hands on a really unique piece of computing history here. This is the Intel Extreme Series D5400XS, a $650 motherboard that didn't work without two $1,500 CPUs and anywhere from $250 to $500 worth of special memory. Not 100% sure what the pricing was like. Information going back that far is a little scarce, because all that pricing that I just fed you guys is based on information that I could find from 2008. Yes, my friends, this right here was the heart of a system that, once you account for graphics cards, power supplies, case, drives, cooling, could easily cost you $5,000 to $7,000 for a finished tower, right up there with the most expensive enthusiast systems today. Now, at the time, one of the main criticisms of the Skull Trail platform was its high price to performance ratio, especially because at the time, well, it was hard to find applications that scaled beyond 2 cores. But how has it aged? There's only one way for us to find out. By sitting through this segue to our sponsor. This thing is in absolutely incredible condition. Like, even all the original documentation and accessories and stuff are in here. Here's a copy of Ghost Recon Advanced Warfighter 2 if you're into that. It's even got the door hanger. Fraggers only. Noobs beware, you'll be pwned, mother.
Fraggers.
Put that on my door. Now, the first thing that jumps out about the board itself is, of course, its massive size. So eATX motherboards like this were extremely uncommon outside of the server space at that time, but it's not like it wasn't this big for good reason. It was absolutely packed with cutting edge features for that era. So it uses the LGA 771 socket, or rather I should say 2 of them, which supports Xeons, but also the unlocked and overclockable Extreme Edition QX9775. Now, the Xeon platform was chosen for one main reason. The consumer chips had a different pinout that didn't support multiple sockets, and the goal here was to create an 8-core platform several years before AMD would release their first consumer 8-core CPU, and 6 years before Intel would release its own. So then, what we're dealing with here is 2 of Intel's 3.2 gigahertz Yorkfield Extreme Edition CPUs connected over a 1600 megahertz front side bus to a 5000 series chipset, which we can find right in the middle here. That right there provides our CPUs with all the connectivity that they need to memory, expansion slots, and all of your rear I/O and all that good stuff. Now, one of the funny things about this system is how normal it looks. Like, here's your SATA ports where your hard drives go. Here's your PCI Express slots where your graphics card goes. There's nothing about it to really immediately indicate that it is 11 years old, unless you start to look a little bit closer. Let's talk about the memory. These are really special. So they use commodity DDR2 DRAM chips, but they're actually not intercompatible with DDR2. These are called fully buffered DIMMs, or FB DIMMs. So one of the big challenges of pushing memory speeds and capacities up is the complexity of designing the traces between the memory and the controller. So in this case, that's on the North Bridge, but in a modern system, that memory controller would be on the CPU itself. Now, one of the ways to reduce trace complexity and reduce load on a memory controller is to move to a serial bus rather than a parallel one. So in simple terms, they decided that instead of having the controller communicate directly with the memory chips on the module, they put a chip called an advanced memory buffer onto every module that would act as a go-between, buffering all the read and write requests. Now, this extra chip here is not to be confused with the extra DRAM chip on ECC memory that's used in modern workstations and servers for error correction. Now, the AMB came with a penalty to both write speed and to latency because of the additional communication step. But at the time, Intel thought that this trade-off would end up being worth it for the future improvements in capacity that never actually materialized. By the next generation, Intel ended up following AMD's lead, moving the memory controller onto the CPU, and they ended up setting the stage for the ultimately successful plan to increase memory slot counts, which was adding more memory channels to the CPU itself. Okay, so one of my challenges getting this thing up and running was actually finding some coolers that had mounting hardware for such an old socket. Fortunately, I happened across a couple of these old Gemin 2s. These things are kind of jokes to mount, but I didn't really have a choice. They were the only non-water cooling things that were still compatible in our warehouse, and I didn't feel like rigging water cooling up to it.
This time.
There is just something about a dual socket system that just gets my inner geek going, you know? Before we boot it up, there's a couple more things I want to appreciate. One is the onboard power and reset switches. That was pretty cutting edge for the time, even if the I/O hasn't aged so well. USB 2, FireWire, and eSATA? I guess 1 for 3 ain't bad for standards that were going to still exist 10 years later. And this is really unique. So you've got your 4 PCI Express 16X slots here, but at the time, no chipset could actually directly run 4 PCI Express 16X slots. So how did they do it? So check this out. Intel's Southbridge needed some kind of a solution to increase the number of PCI Express slots. And what they used was actually 2 NVIDIA PCI Express switches, which would each take 16 lanes and split them out into 2 slots with 16 lanes each. So what this meant was, from NVIDIA's driver's perspective, all of the GPUs in the system were actually connected to an NVIDIA chipset, meaning that Intel didn't have to resolve the licensing dispute in order to support SLI on this particular motherboard, even if none of their others could do it. Well, some of these holes line up. Good enough. Power connectivity is almost identical to a modern board. We're just gonna run a regular old SATA SSD off it. Yay, backwards, forwards compatibility. And then theoretically, I can just throw my Titan-X test bench card on here and it should just fire up. Okay, and a 1, and a 2, and a... Good luck, everybody. And we're up. Hey, hard drives detected, SSD rather. Excuse me, old habits die hard.
There's more, yeah, there we go. So stealthy.
It's refreshing.
No!
So that was painless. Just fired up a drive I already had set up and bippity boppity, no drivers required or anything. That's it, modern Windows 10. Now, this is cool. One fun thing about this generation of hardware is that because the CPU bone's connected to the Northbridge bone is connected to the memory bone, we don't have to deal with the performance penalty where modern dual socket systems can experience worse performance when this CPU needs something from the memory that's directly attached to this one, causing an extra communication hop. So you can actually see here, all of our cores show up as a single NUMA node, which should allow basically any workload to scale well across all 8 of our cores. I mean, except for the fact that we have a Northbridge, so there's just like always an extra hop. I mean, with that said, overall system responsiveness here is super usable. Like with an SSD drive in here, I would have no reason to think, unless I opened up Task Manager, that I'm looking at a super old computer here. Like, everything just kind of works. So while it's definitely not modern, there are some really good things about this setup. Like, this is about as far back as you can go while still maintaining most of the modern creature comforts. Like PCI Express, even Gen 1, means that we can add high-speed connectivity to this system. You want 10 gig networking, which I just installed, boom, an add-in card and you're ready to go. You want USB 3, boom, another add-in card, you're ready to go. Like PCI, the older generation, which by the way, it does also have a couple PCI slots in there, capped out at 133 megabytes a second, and that was a shared bus. So multiple cards plugged into multiple slots all had to share that limit. PCI Express, even the first generation version featured here, could handle up to 4 gigabytes per second on a slot like this one. Okay, so it occurs to me that we're gonna be limited by our SATA 1 drive, but I'm copying a file over the network here and we are out of disk space. One moment, please. At any rate, we should still be able to tell if we're getting an actual 10 gig connection to our server here. It should exceed 112 megabytes a second, and boom, there it is, 183 megabytes a second, which is well shy of 10 gig, but certainly more than 1. What's our CPU usage look like doing that? Oof. So let's come up with some more realistic workloads then. I mean, what about 4K YouTube? Remember guys, this is 2000, holy shit, this was in 2008. Yep. Remember when YouTube looked like this? 4K YouTube was just a twinkle in the engineer's eye when this system was released. So let's see if it can handle it. There it is, ladies and gentlemen. 4K YouTube playback, butter smooth. What does that cost us in terms of CPU usage though? Actually, that's not even that bad. We're sitting at around 20% CPU. Now, I'm not saying to get too excited about this, because 20% CPU on this system is about, oh, it just spiked to 300 watts, but about 250 watts from the wall, which, considering that a modern smartphone can also play back 4K YouTube in the single digit watts is, well, it shows you that we've definitely come a long way in the last 10 years. As for multitasking, well, even just trying to browse the web in the foreground while our 4K video plays in the background, we're gonna see spikes in CPU activity up in the range of 60 to 70 or even 80%, depending on how heavy the pages we're trying to load are. So you can actually see each page load here as it's coming in. Oh wow, loading a big Google sheet actually got us up to 75% CPU usage. But our video is still playing back smoothly. We can scrub around, like all the features work exactly like you would expect them to. Now to see how well it's aged in terms of productivity, let's fire up Photoshop Creative Cloud. Ed, you wanna try and do something on this? Let me know if it's any good.
Alrighty.
Here's some coil line, it's working there. Is that a reasonable amount of time to open this file?
That's pretty quick, yeah.
Maybe close Task Manager in the background. Oh wow, we're at 100% CPU. What are you trying to do?
I was just duplicating that layer. And it's a flat layer. Wow.
You can actually hear the fans ramp up. Oh wow.
Oh, there you go, just needed to catch up.
Now I kind of wonder if a big part of our problem could be that we've only got 8 gigs of memory. Oh, so we're only letting Photoshop have up to 5 point something gigs.
That's not the worst thing ever, actually.
It's not great. I mean, your workstation doesn't perform like this, does it?
No, but I mean, this is 10 years old.
Yeah, this looks pretty unusable to me.
I mean, resolutions have gone up since then, so.
I mean, it's just loading things for days. All right, thanks, Ed. Are we even gonna be able to close Photoshop?
Yeah, eventually.
Now, I was kind of hoping that the Photoshop test would go okay so that there would be some suspense when I fire up Adobe Premiere, but all signs point to this just being a bloodbath.
Is that worse than a bloodbath?
It's much worse. Give it a second, it's popping in, popping fresh, you know? Got that fresh content. All right, that's it, all media loaded. Let's see what kind of performance we can get here. Woof! Now, in fairness, this is 8K footage, and we're trying to play it at half res. Quarter res? Oh, nope. That's ugly. Let's try 1/8. Okay, maybe 1/16? Okay, so it's not completely unusable, but only at 1/16 quality. You can see now at least my scrubbing performance is quite a bit better than it was. I can move around on the timeline and actually get a preview in a reasonable amount of time here. So this is grayed out, but that game definitely launched. This is some strange behavior. Oh yeah, we're trying a game now. Theoretically, the higher resolution you go, the more likely you are to be bottlenecked by your graphics card rather than your CPU. So I'm gonna try and run Anno 1800 at 4K resolution. Now the menu's at 60 FPS, that's not a bad side. Shut up, David. There we go. And no, that spectacular menu performance did not translate to in-game. So this card should be good for 45 to 50 frames per second at these settings. Somewhere in that range. This is clearly not that. Now what's kind of cool is you can really see G-Sync in action when you zoom in and you manage to get like a decent frame rate. So we're up to around 30, but it doesn't manage to account for like panning, and also the game just crashed. G-Sync cannot help you with that. Wow, this is one spectacular game crash. Like I can't even get Task Manager up. Sign out. That'll do it. See, this is the thing that kills me about Windows. They can't code an actual, no, end the task. But if you sign out, it's like, oh yeah, you wanna end the task? No problem. Okay, so in fairness to our system here, I did choose Anno knowing that it's a particularly CPU heavy game. So why don't we try something a little bit more fair? This here, eventually, is going to be Rocket League. Again, 4K, high quality, with motion blur off. And actually, this is quite playable. I mean, I still suck at this game or whatever, but the good news is that we're running it anywhere from about 50 to 65 frames per second. It actually plays pretty darn nice. Especially again, like I said, with G-Sync, a feature that they couldn't possibly have imagined existing back when they were creating this motherboard and CPU combo. Thing is, guys, my secret plan all along was actually to outfit this thing with $2,500 worth of modern gaming horsepower. That's right, I wanted to run 2 RTX 2080 Ti's on it in SLI. Now, the thing is though, it's gonna take some time to get SLI working because there are actually issues with Windows 10's driver support for those NVIDIA PCI Express bridges that we need. Oh crap, I just realized I forgot to plug the chipset fan back in. That's hot. All right, so anyway, that's gonna take some work. Also, some of the things we've tried so far have been pretty slow. We're running into obvious CPU bottlenecks. Maybe overclocking's the solution? Well, that's gonna take some time as well. Another thing, 8 gigs of RAM is obviously a problem for productivity, but it may even be a problem for gaming for us at this point. Intel only ever validated this motherboard for 8 gigs of RAM, 4x2 gigs. So I'm just gonna have to source some 4 gig fully buffered DIMMs and just see what happens. Also, I think there's some software optimization that we can do. So game launchers, it's gotten to the point where you need 2, 3, 4, maybe even more of those running on your system. And on a modern system, something like the Uplay launcher is a negligible amount of system overhead, not enough to affect performance unless you're running like comparative benchmarks or something. But on a system like this, having Uplay in the background, look at this, just launching it spiked us up to 80%. And having it running in the background sucks up as much as 8 to 10% of our CPU performance. So to put that in context, that is about 2/3 of one of my 8 cores. Like, okay, Anno still wasn't gonna run well on this thing, but having stuff going in the background certainly isn't gonna help. So then, I wanna hear from you guys. What are your suggestions in the video comments for what you wanna see for part 2? And I also want to hear from you guys what you think of this segue to our sponsor. So thanks for watching, guys. If you disliked this video, you know where that button is, but if you liked it, hit like, get subscribed, or maybe consider checking out where to buy the stuff we featured at the link below. Also down there is our merch store, which has cool shirts, like the one I'm wearing, cool water bottles, like the new LTT Stealth water bottle. And also we have a link to our community forum down there, which you should definitely join. Still cold. insulated bottle.